Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where we are discussing all the chapters, all the concepts, all previous year questions along with weekend test. So in the Sunday morning I am giving you 30 questions to answer, and at night I am back with the answers to those 30 questions. So if you are not yet subscribed to our WhatsApp channel, I request you to join our WhatsApp channel. The link is given in the description. From there you can download the weekend question paper. From there you can download the class notes. Whenever I am teaching in class, that note you will receive via WhatsApp link. Also we will be giving you the question papers for weekend test. So don't forget to join our WhatsApp channel if you are interested in scoring a very good marks in KCET 2025 absolutely free. Okay, so let's start with the journey today. So what all we are going to discuss? We are going to discuss moving charges and magnetism, Bio-Savart's law and current loop. So we are going to discuss mainly these two concepts today, and first of all we will start with magnetic field due to a current element, that is the Bio-Savart's law. Okay, next we will discuss magnetic field due to a straight conductor. Then we will discuss magnetic field versus electric field. There is a small comparison between electric field and magnetic field. Then we will discuss a very important and interesting concept, mu naught and epsilon naught. Then magnetic field on the axis of a current carrying loop. So these are all 5 concepts that we are going to discuss today. So let us start with Bio-Savart's law. So suppose I have a conductor here, okay, a conductor carrying current, okay, like this, and I want to find magnetic field at this point due to this small portion, okay, this small portion dl. I am saying this small portion is dl, and I am interested in calculating the magnetic field at this point, say dBp, okay. That is our objective. Now what I should do? So there is a pair of scientists, Bio and Savart. They gave a law that says that this magnetic field, okay, the small magnetic field due to this current element, okay, depends on few things. First of all, it is proportional to the current through the element. So suppose I current is passing through that element, so BP dBp is proportional to current element, sorry, current through the element. It is proportional to the length of the element. If the length is small, okay, dBp will be small. If length is large, then dBp will be large, okay. It is proportional to the length of the element, and it is inversely proportional to the square of the distance. So how far you are measuring the magnetic field. Based on that, if it is too far, a magnetic field will be very small. If it is close, magnetic field will be stronger, because it varies with inverse square law, okay, similar to Coulomb's law. Also, it is proportional to the angle sin theta that this dl element makes with the direction, okay. Suppose this is a vector. I will explain that vector form in a while. Now suppose there is a vector dl and r is also vector, then the angle between them is theta, then it is also proportional to sin theta, okay. The theta is shown in the diagram. Now combining everything, we can write this as dBp is mu naught by 4 pi I dl sin theta by r square. Now what is this mu naught by 4 pi? Let us discuss about that. Mu naught by 4 pi is 10 to the power of minus 7 Tesla meter per ampere. Okay, we have learned 1 by 4 pi naught, 1 by 4 pi epsilon naught, if you remember, it was equals to 9 times 10 to the power of 9, right, SI units. Similarly, in magnetism, magnetic field, mu naught by 4 pi is the replacement of 1 by 4 pi epsilon naught. In electric field, everything is related with 1 by 4 pi epsilon naught. In magnetic field, we use mu naught by 4 pi instead of 1 by 4 pi epsilon naught. This is basically related to electric field. This is related to magnetic field. Now what is the what is mu naught? Mu naught is permeability of free space. Okay, if you remember, epsilon naught was permittivity of free space, mu naught is permeability. So it measures how much it can, how much electric field can pass through in vacuum. Here how much magnetic field can pass through vacuum. Okay, basically here also we assume the medium is vacuum. Okay, there is nothing is there. If medium is present, this equation becomes little complicated. That we will study a little bit in our next chapter, not in this chapter. Now, if I write this as a vector form, there is a vector form as well. Okay, then dBp becomes mu naught by 4 pi. Okay, now I is not a vector, dl is a vector and r is a vector. So, you can write this in two ways. One is dl vector cross r cap divided by r square without changing the r square in the denominator. That is one way of writing. Now, what is the direction of dl? dl is in the direction of current. Okay, dl is in the direction of current. So, since this is a curve, okay, this is a curve, right? So, for a curve, the direction of current will be tangential at that point. So, it will be tangential. So, here I have drawn a tangent. Okay, this is a tangent. Okay. So, remember that whenever there is a curved line, okay, the direction should be along the tangent. Okay, it is not in this direction. It is not in this direction. It is in direction along the tangent. That is the property. Okay. Similarly, another way you can write. Sometimes they ask you in objective if it is given by dl cross r vector, then since we have added one extra r in the numerator, it will be r cube in the denominator. Okay, there once there was a question came that if magnetic field is given by B vector is equal to mu naught by mu naught by 4 pi, sorry, mu naught by 4 pi, okay, and they have given you I dl cross r divided by r cube, okay, divided by r to the power x. We will see one such question in our today's class as well. Okay, r to the power x and what is the value of x. So, remember that when there is r vector in the numerator, value of x will be 3. If this is r cap, it will be square. If it is in scalar form, it will be square. Okay, so this is the scalar form. These are the two possible vector forms. Now, why we are using this term dB? Okay, instead of using for example, why we use dx? When we use dx? When it is due to a very small element, right? The element tends to goes to 0. So, basically here dl is a very small element because this is a very large wire and its geometry and construction is different, right? So, to find the total magnetic field due to the entire wire, we have to use what? Integration, because this is a differential form. To find the total magnetic field, we have to use integration. Okay, now based on the shape of the wire, it will depend on the shape of the wire. If the wire is complicated, we may not use this formula. There are other formulas as well. We will learn a little bit alternating and easier formula than Bio-Savart's law, but Bio-Savart law as a formula is important. Sometimes they will ask you directly based on Bio-Savart's law. Okay, that is why this formula you should remember. This is the main formula. Okay, this formula you have to remember. Okay, this is just for your understanding that sometimes they will ask you in terms of vector. So, in terms of vector, instead of r square, it becomes r cube because you are writing r vector here. Okay. Now, magnetic field due to a straight conductor, straight infinite conductor. I have a straight infinite conductor. It is coming from somewhere, it is going to somewhere. Now, if this is a straight conductor, we can do the integration. Okay, I am not doing the integration, but after doing the integration, if you find the magnetic field at this point BP, then you can calculate that magnetic field using this formula. Okay, BP is equal to mu naught by 2 pi I by r square. There is another alternative proof of that using Ampere's circuital law. We will do that in our next class. Today we are not discussing Ampere's circuital law, but it can be proven from Bio-Savart's law as well. It can be proven from Ampere's circuital law as well. Okay. unless and until it is mentioned. It is better to derive. If you are preparing for PU board, you should prepare it using Ampere circuit law. That is very easy, but the formula can be derived from Bio-Savart's law as well. Okay, and this formula is very important. You have to remember this formula. Mu naught by 4 pi was Bio-Savart's law. In this case, it is mu naught by 2 pi I by r square. Mu naught by 2 pi I by r square, and you should remember that this wire is infinite. Okay, it is not finite wire, it is an infinite wire. Okay. Now, magnetic field versus electric field, small comparison is here. What is the comparisons? Let us see. Both are long range, obviously both are long range, since both depend inversely on the square of the distance from the source to the point of interest. Obviously, both are inverse square laws. So, as you go to infinity, it is still there. Before infinity it is there, at infinity it becomes 0. So, basically it means that it is a long range force. Okay. The principle of superposition applies in both fields. Obviously, principle of superposition is multiple current carrying wires are present, or multiple source of magnetic field is present, they add each other. Okay. Similar to that of electric field, when we said there are two charges, then total magnetic field will be, total electric field will be sum of the charges, right. Similar to that, principle of superposition also applies. The electrostatic field produced by a scalar source, that is charge. Okay. So, in case of electrostatic fields, we are considering charge. Okay. Charge is basically responsible for producing electric field. It is a scalar quantity. Okay. But magnetic field is produced by vector source. Okay. In this case, ideal. If you see, magnetic field is produced by a vector source. Source of magnetic field is a vector, source of electric field is a scalar. Very important line, you should remember this line. Maybe based on this line, they will ask one question in your, either in your PU or in your KCET, you do not know. This is a very important, interesting line. Okay. Next is, the electrostatic field is along the displacement vector joining the sources and the field point. Okay. The magnetic field is perpendicular to the plane containing the displacement vector and the current element IDL. So, basically what is the meaning of that? In case of electric field, if you see, it is on the same plane as the charge, right. In case of electric field, it is on the same plane as the electric charge. In case of magnetic field, we have seen that, okay, current is flowing in this direction. So, suppose this is DL. Okay, we are finding magnetic field at some distance here, dB, okay, and current was I. So, IDL is the element, right, IDL is the current element, and we know that it is a cross product. Now, in case of cross product, how can we find the direction? To find the direction of cross product, first of all, we have to start with the first quantity, that is ideal cross R, right. So, ideal cross R means ideal. Okay, in this direction, first I will arrange my fingers in the direction of the first vector, then I will rotate my fingers in the direction of the second vector. So, ideal, okay, and I will rotate it. So, at this point the magnetic field is into the paper, page into the paper. Okay. If I consider magnetic field here, okay, so R will be in this direction, in that case it will be out of the paper. Okay. First this direction, then I will rotate towards the R vector. So, it will be out of the paper. Okay. So, in case of cross product, first of all we have to arrange our fingers in the direction of the first vector, then based on how it is arranged, okay, based on that I will rotate my fingers towards the second vector. Okay. I have to arrange it. If it is in this direction, I have to arrange like this. If it is in this direction, I will arrange like this. So, this is the direction. Okay. The thumb points the direction. In this case, it is into the paper, it is out of the paper. So, basically in magnetic field is basically not in the same plane as the elements are. Okay. So, but electric field is thus in the same plane, right. In fact, if you consider any surface here, it will be perpendicular, right, because if you draw a tangent, it will be perpendicular. In case of magnetic field, it is completely in a different plane, right. What else? There is an angle dependence of the Bio-Savart law which is not present in the electrostatic case. The magnetic field at any point the direction of dl dashed line is 0 along the line q equals to 0, sin q equals to 0 and dB equals to 0. This is not q, this should be theta. Okay. So, we have seen that electric field does not have any angle component associated with it, but in case of magnetic field there is a sin theta component. Okay. So, if theta is 0, then sin theta is 0, if theta is 180 degree, sin theta is 0. So, B is also 0 in that case. Okay. So, basically what does it mean, that if current element and the point are in the parallel direction, then it becomes 0. Okay. The magnetic field becomes 0. Okay. Previously, in case of moving charges, we have studied motion of a charge in a magnetic field. Here we are trying to establish the magnetic field itself. So, first, in case of electric charges, we have done in the opposite way. First we studied the charges, okay, then from there we studied the electric field, then from there we have studied how it will behave if we keep an external charge in an electric field. Here we started with something else. We started with the charge inside a magnetic field, then we are now discussing how moving charges can produce magnetic field. Okay. So, remember that, just for a little bit fun. Now, this is a fun derivation, that is why I kept it, otherwise I would have only given you the result. So, we know that mu naught epsilon naught, mu naught is from magnetic field, epsilon naught is from electric field, right. Now, let us multiply these two terms. Now, when multiplying these two terms, I can add one 4 pi here, another 4 pi in the division, right. I can multiply and divide by the same term. So, what I have done, I have multiplied 4 pi in the numerator and divided 4 pi in the denominator. Okay. Now, what we have done, now we know that 1 by 4 pi epsilon naught is 9 times 10 to the power of 9. So, 1 by 4 pi epsilon naught is 9 10 to the power 9. So, 4 pi epsilon naught will be 1 by 9 into 10 to the power of 9, right. And mu naught by 4 pi, I already told you it is 10 to the power of minus 7. So, just let us keep the values. Now, this will come down and it will become positive. So, I have written this as 9 times 10 to the power of 16. Now, 9 times 10 to the power of 16 can be written as 3 times 10 to the power of 8 whole square. Now, what is 3 times 10 to the power of 8? Okay, maybe you are confused about the units. If you put the units, you will get this unit as this term as 3 times 10 to the power of 8 meter per second entire whole square. Okay, now tell me, what is this quantity known as? This quantity is known as velocity of light in free space. Okay. So, from there we can write 1 by mu naught epsilon naught is basically 3 into 10 to the power of 8 c whole square, or 1 by mu naught epsilon naught is equals to c square, because c is the speed of light in vacuum, that is 3 into 10 to the power of 8, right. So, multiplying two terms completely different subjects, one from magnetic field, one from electric field, applying them we are getting a term which is a constant, that is speed of light in free space, right. So, this is a complete constant. So, from there I can write c is basically equals to 1 by mu naught epsilon naught. This in a way establishes the relationship between electromagnetic wave. Okay. When we are discussing electromagnetic wave, we will know that whenever we are calculating the speed of electromagnetic wave in a medium, we will use this formula. Okay. And this is one way also relating that electric field and magnetic field are not different, they are linked with each other. Okay. And that is why it is called electromagnetic. If you see electromagnetic, electro and magnet are brothers, cousin brothers, even though we are studying them differently, we are studying them separately, because if we combine them together right now at your current stage, it will be very difficult for you to pass your physics exam. If physics is already hard and if we start making it harder, then you will obviously say, okay sir, I am fine, I will not appear for physics exam, physics is tumba hard. But no. So, just to simplify the physics, they have kept electric field and magnetic field separate. So, you have to study 2 chapters instead of 1, but that is for your own benefit only. Okay. Now, so this is one formula that you should remember, that C is basically 1 by mu naught epsilon naught. Sometimes they might ask you what is the relationship between C and mu naught epsilon naught as a form of MCQ. Okay. So, you should remember this formula. Now, let us solve the homework questions. Okay. A strong magnetic field applied on a stationary electron. The electron moves in the direction of the field, moves in opposite direction of the field, remains stationary, starts spinning. Okay, I know most of you have answered start spinning, most of you are thinking it will start spinning, but remember that force on an electron is Q V cross B or QVB, right. Now, here it is said that stationary electron means V is 0, force is 0. So, magnetic force will not act on this electron as long as the electron is at static condition. No matter how strong magnetic field you apply, okay, it will not affect anything, it will remain stationary. So, when I am teaching in your class, no matter how good a teacher I am, if you do not take your study seriously, your score will remain 0, right. No, you are studying, okay, very good. Now, let us move on. Second problem, a metallic rod of mass, I gave you a diagram also for to solve this question. The diagram was like this. Okay. A metallic rod of mass per unit length 0.5 kg per meter is lying horizontally on a smooth inclined plane which makes an angle 30 degree with the horizontal. A magnetic field strength 0.25 Tesla acting on it in the vertical direction when the current I is flowing through it. When the rod is allowed to slide down, the quantity of current required to keep the rod stationary. So, current is flowing into the, suppose it is flowing into the paper, into the plane, okay, inside the plane. Now, we know that the magnetic field is in horizontal direction, vertical direction. So, magnetic field is in this direction, okay. So, what will be the direction of magnetic field? So, into the paper upside. So, it will be, if you apply the left hand rule, okay, magnetic field will be in this side, okay. So, magnetic force will be in this side, cross product. Okay, either you can use left hand rule or you can use cross product rule, whatever you will use, you will see that the force acting on this wire is in this direction. Now, what all are the forces acting on this? Another force acting on this is the weight, okay, weight of the object, right. So, weight of the object mg acting downward, okay. Now, how can we establish an equilibrium for this wire? Okay, so, the angle given here theta is 30 degrees. Okay. Now, if I take component of mg, you have learned that in your first PU. If you have not learned it, go back, study little bit and find out what happens when, how to find the components when it is placed in an inclined plane. What are all the components? For friction chapter, I am giving you a hint, friction chapter, work done chapter, go there, study little bit about the direction, right. Now, in this case the component is mg sin theta, right. Now, this FB should have a component in this direction which should balance this component so that the wire remains stationary. Now, what is this component? If this angle is 30 degrees, then this angle will be same. This is a similar angle, right. If this angle is 30 degree, this angle should also be 30 degree, right. They are parallel, okay, similar angles. So, this should be FB cos theta. Now, many of you have done a wrong thing by assuming that this force is Bill sin theta. So, Bill sin 30. No, here magnetic field and current are already perpendicular. Okay, so, in that angle is 90 degrees. So, Bill sin theta, Bill 90 degree is 90 degree 1, right. So, we are not having any BIL, only BIL should be here. Okay, only BIL should be here, right. Now, what is mentioned that the metallic wire of mass per unit length is 0.5 kilograms. Okay. Now, we are assuming the length of the wire is B into I into L. Okay. Now, mass per unit length means total mass of this wire will be, suppose mass per unit length is mu. This is one of the way of representing mass per unit length. So, if mass per unit length is mu, then that should be equals to m by L. So, m should be mu L. Okay. So, here we have to use these things, and only condition for balance is mg sin theta. Now, I wonder some of you who are preparing for higher order exams, they are thinking what will happen to the other component of the force, that I will discuss as well. So, that is equals to Bil B-I-L cos theta. Okay. This cos theta is coming as a component, not from the theory, not from the formula. Okay. This is coming from the component. So, remember that Bil is Bil. Okay. Sin theta, in that case theta is 90 degrees. So, only Bil is there. Now, m is mu L G sin theta equals to B I L cos theta. Okay. So, L cancels. Okay. So, what is the question? Question is find the quantity of current. So, we are trying to find the current I. So, I is basically mu G sin theta divided by B cos theta, right. So, mu was given, what are all the values? Mu was given 0.5 kg per meter, okay. Angle given 30 degrees and magnetic field is 0.25 Tesla. Okay. So, mu is 0.5, G assume 10, sin 30 by cos 30 which is tan 30, okay. Sin theta by cos theta is tan theta, and tan 30, okay. Tan 30 is 1 by root 3, right. Sin theta is 1 by 2, cos theta is root 3 by 2, then it will be 1 by root 3 divided by B is 0.25, okay. Tan theta we have taken already. Now, 0.25 divided 0.5 is 2, okay. So, it will be 20 divided by root 3. Root 3 means what? Root 3 means 1.7, okay. Root 3 is 1.7. So, you can cancel that. So, 20 divided by root 3. Now, if you use the value of root 3 here directly, it will be little longer. So, what we will use? We will use 20 root 3 divided by 3, right. You have learned that. Now, assume this 20 to be close to 21. I can assume that. So, 21 approximately, we are doing approximated values. So, do not worry about this if answer does not match exactly. So, we are getting 7 root 3. Okay. Now, 7 times 1.7 approximately. So, 7 is 7, 7 7s are 49. So, it will be 49, 11.9. So, 11.9 is the answer, closest to that number, slightly less than that. So, 11.32 should be the current, okay. 11.32 is the close less than 11.9. Now, why I am saying less than? Because here we have increased the number in the numerator. So, increasing the number in the numerator means final answer should be slightly less than whatever we have calculated, okay. So, the correct answer is 11.32. Okay, this is a approximated value. As I told you, always do good approximation. A good approximation is as good as your correct answer, right. Now, magnetic field on the axis of a circular current carrying loop. So, suppose we have a current carrying loop of radius capital R, okay, and we want to find magnetic field at a distance, say x from the center, okay. We want to find a magnetic field at a distance x from the center, some point, okay. At some point P, we are trying to find the magnetic field. Now, how can we calculate that? There are two formulas for that. First formula is B equals to mu naught I r square divided by 2 x square plus r square to the power 3 by 2. The derivation I am not doing here, okay. If you want the derivation, you can go check your NCERT book or in your guidebook, whatever you are following, but this formula you have to remember, okay. Derivation is one part for PU board, okay, but you have to remember this formula. This is very, very important. Not only the shortcut formula mu naught I by 2r, also this formula. Both formulas are important for KCET. For PU board, any questions coming, any derivations coming, if you skip some steps and finally write this formula, okay. But in KCET, you have to remember this formula if you want to score 60 out of 60. Okay, if you are happy, okay, maybe 1 or 2 questions I will leave. Now 1 or 2 questions in each chapter means 28 questions gone, right. So 32 will be answering, okay. This is a difficult concept, I will leave. This is a difficult concept, I will leave. You cannot do that, okay. You have to remember this is slightly odd formula, okay. Mu naught, only if you remember this formula is a consequence of that, okay. If you put x equals to 0 in this case, you will get at the center of the circle. Center of the circle means x should be equals to 0, right. Center of the circle means x is 0. If you put x equals to 0, you will get this formula. So, only one formula that you need to remember is this, mu naught I into r square divided by 2 x square plus r square to the power 3 by 2. If you put x equals to 0, okay, r square to the power 3 by 2, that is basically r cube. So, r cube and r square will cancel. So, you will get mu naught I by 2r, okay. Now, let us look into one of the KCET question, KCET 2020 question. Okay, you might be thinking that, okay, sir, I do not need to remember that question, no question comes from that. Question does come from that, my dear students. So, you cannot ignore that. Now, what is the question here? Question is, in the given figure, magnetic field at O, okay, magnetic field at O. So, easy thing is that they have not asked you along the axis, but they have asked you question on the center. So, one thing is easy. So, first of all, what is the magnetic field at the center if the circle was whole? If the circle was whole, the magnetic field at the center would have been mu naught I by 2r, right. So, mu naught I by 2r should have been the magnetic field at the center of the circle if it was whole. Now, if you consider the circle, if you divide the circle into 4 halves, okay, this is 1 half, this is 2 half, this is 3 half, this is 4 half. So, for 4 halves, okay, 4 parts of the circle, this was the total magnetic field, right. So, for 4 halves, this was the magnetic field. Now, how many halves are there in the given circuit? In the given circuit, this is no longer there, right. This is no longer there, right. This was an imaginary part that we considered. It is no longer there, right. So, what we will do, for 4 parts, this was the magnetic field. How many parts are here? 3 parts are here. So, for 3 parts, the magnetic field will be 3 by 4, okay. For 4 parts, entire thing, okay. For 3 parts, 3 by 4, right. Like a pizza, you are dividing the pizza. Remember that 1 half is already eaten by someone. So, how you will divide? You will divide 3 halves, right, 3 by 4, right, 3/4. So, 3/4. Now, this is not done. This is only the magnetic field due to the circle we have calculated, 3 mu naught by 8r, right. Now, that is only 1 half. Now, there is also a, if you see, there is also a straight wire which is carrying current, okay, straight wire carrying current in this direction. Now, the formula that we have learned for straight wire was for a infinitely long. Now, this way it can be infinite, this way it can go and it is infinite. This wire is no longer is not affecting because this is along the parallel, okay. So, theta is 0 in this case. So that's why it is not affecting, but in this case theta is not 0. So what we have to do, we have to construct an imaginary half for this wire as well. So this wire, I mean, assuming that this was an infinite wire carrying current in this direction, infinitely long wire, then what was the electric field due to an infinite wire? Infinite wire, we already studied that as well, mu naught I by 2 pi r. So mu naught I by 2 pi r square, that was the formula due to an entire long infinite wire. Now here how much of that wire we have? We have only half of that, right? So similarly, using the same logic for the entire wire, the magnetic field was mu naught I by 2 pi r square. For half of that, it will be mu naught I by 4 pi r square. This is a very thematic question, very thematic problem. If you have done some homework, if you have done some study and homework, then this type of problem should have been easy for you. Okay, this was not very far. Okay, only 4 years back this question came. Okay, so the magnetic field, the net magnetic field. Okay, now this magnetic field and this magnetic field are in the opposite direction. Okay, the magnetic field due to this is in this direction, and magnetic field this due to this is opposite direction, it is into the paper. Okay, so you can calculate. Now magnetic field due to this loop will be, if you bend your hand in the direction of current, if you bend your hand in the direction of current, then your thumb will show you the direction of magnetic field. So if you rotate in this direction, so it will be into the page. And what is the direction due to this? So it is flowing in this direction. So what we have to do, you have to now for a straight wire, it is just opposite. You will point your finger in the direction of current and you will rotate your hand. So in that case, it will be into the page. Both cases it is into the page, right? Both cases into the page. So the net magnetic field will be addition of that. So 3 mu naught I, okay, there is a I here, mu naught I by 8 r, okay, 8 r. Instead of some capital R, here it is given as small r, right? So we can simply use small r here. Okay, so it will be plus, both are in the same direction, so mu naught I by 4 pi r square. If you look into the options, there should be a square here, somehow it is missed. Okay, so the correct answer is option A. Okay, so correct option is option A. You should be careful. This is a very tricky question. Mainly both of the concepts are from magnetic field only, but this is a very tricky question, especially this straight line path. You may be figuring out, okay, this is the for circular, entire circular coil, this is the magnetic field. So for 3 parts, this is 3 by 4th magnetic field. This is a very joint entrance, JEE main style question. Okay, this style of questioning is very common in JEE mains. So if you are preparing for JEE mains, you may be able to answer this question, but if you are only preparing for KCET, you have to understand and prepare a lot in depth to answer this question, right? Now next move on. I have given you 2 particular homework for this chapter. Let's look into the question number 1. You can pause the video, read the question, answer it and mention the answer in the option in the comment below. And this is the second question. Again you can pause the video. This is very interesting question and easy question obviously. You can pause the video, look into the question, okay, answer the correct option in the comment below. And whatever videos we are doing in our channel is uploaded in this playlist, KCET 2025 Physics 100-day challenge. Okay, you can go and check all the videos, all the lectures that is been already completed, all the chapters from where you might be facing difficulties. Also remember, all chapters from second PU are very important, so we are taking time and doing it slowly. Okay, when we come to first PU, we will go in a faster pace. So don't miss out on any of the lectures that we are doing on our channel. That is for if you are preparing for KCET 2025 exam. Okay, also join our WhatsApp channel for KCET 2025 weekend test series. Okay, and if you like our videos, if you are watching this for the first time, don't forget to subscribe to our channel. Thank you for watching this video.